Okay, so today we're going to look at coding within Unity, scripting within Unity, variables, functions, classes, and how to use them. What is scripting in Unity? I like to think of it like the old Jewish legend of the golem. Do you know the Jewish legend of the golem, the Dybbuk? Can you tell me the legend of the golem? Tell me the legend of the golem. Can you shine a light under your face like it's a scary story? The legend of the golem. What do you know about golems? What golem? Gollum. Golem. A golem is an ancient Jewish creature that's created by a priest. He's made out of clay, and then he is not alive. He is not dead. But you put a magic script in their head, and they do what the script tells them to do. Game objects are like the Jewish legend of the golem. Game objects by themselves will not move, will not perform any actions. But these scripts, the magic scroll, scripts and the components and how they interact will tell you what is going to happen. So scripting in Unity is different from pure programming. If you've done any pure programming without the benefit of an engine, you're creating a running app. You realize that in Unity, you don't need to create the code that runs the application because Unity does that for you. There's a lot of systems for you, the physics engine, the UI system, the sound implementation, particle systems, all of this is created in Unity. And besides that, the actual engine to run it all, the 3D or 2D engine, is created for you. You just need to focus on the gameplay in your scripts and what you're changing with that scripting. So Unity runs in a big loop. When we press play and start testing our scene, it will read all of the data in a game scene, reading through the lights, the meshes, and what the behaviors are, and processing it all for you. So it's working in frames the way television works, 30 frames per second is standard HD def. Unity is trying to do the same thing. So it's running single discrete frames one after the other. And in gaming, we're always chasing smooth 60 FPS, 60 frames in 1 second. And any kind of lag or slowdown is usually because the game engine can't handle how much detail is on the screen. You probably encountered it in a game yourself. You turn a corner to a big open area full of people, and there's just a second where they're like, and you see the background suddenly go from blurry to clear level of detail and pop in. Back in the N64 days, there was this thing called volumetric fog that was in every 3D game. You could literally see 8 paces in front of you. That's where we got Silent Hill. So you direct Unity with the instructions that you write in your scripts, and Unity executes them frame after frame as fast as they can. Higher frame rate means not only will the graphics look more fluid, but the actual gameplay will be affected. Your scripts will be executed more often, making controls more responsive. So the game will react faster with a higher frame rate. What languages can you use in Unity? Only one of significance. They have support for certain jobs. They used to have Boo support, but right now it seems that the only language they're accepting is C Sharp. Unity is built in C, and then C Sharp is the overlay on top of it. So all the languages that Unity operate in are object-oriented scripting languages, as in they store variables and objects and they orient around them. So scripting languages have syntax, parts of speech, and the primary parts are variables, functions, and classes. Variables, as you know from your other scripting practice, hold values and references to objects. So they can hold numbers, they can also refer to a specific object in your game. Kind of like a box that holds something for us to use. And there's a commonality for variables to start with a lowercase letter, and a good idea to do so because most uppercase lettering in C# refers to a class or a variable type. Functions are things that use these variables. We write them to read these variables and manipulate and react based on what they do. Functions generally start with an uppercase letter, and we organize our code into function. Have you seen an if statement before? I know you have. What will this method produce this function. What is the check? This is the condition. What is the condition? No, if 1 is greater than 2. Yeah. So if 1 is greater than 2, the result will be, it's going to write that in the console, change places. Is 1 greater than 2? No. So what's going to happen then? Exactly, it's going to print OK. So only if this one was greater than 2, but it isn't. This is also, we structure our functions within Unity C#, public or private. Public means to be read from other scripts. And then void or not void. Does anyone know why we write void in front of a function? Perfect. Yes, exactly that. It doesn't return any value. So this is returning this result, but there's no actually returned calculated number or calculated result. So anything with void is not returning a value. Anything without void is returning a value. Thank you. So in Unity, scripts by start by laying out the tools that you need at top, and this is usually by declaring variables. We can set our visibility to public or private at the front, followed by a type and then a name. So this is our type right here. You'll notice it is uppercase for the type. And then the variable name, my other light, is using camel case. And then this is whether we can read it outside in scripts and whether it is private. And if we create this in Unity, as we're about to, we'll see 1 is private and 1 is public. So let's do exactly that. Let's jump into Unity. And I have a brand new blank scene. I'm just going to create an empty game object, create empty. I'll call this light switcher, because I'm going to use this to switch lights. Nope, game object, create empty. Control Shift N is the shortcut. I can't zoom for this part for some reason. What's up? Yep. Okay, did you already install your editor? Okay, we gotta wait till it finishes. Yeah. Well, how long is a piece of string and how fast is the internet? If I was at home, it wouldn't take very long at all, but we're here. So I don't know. This is why I sent this message out on Friday. I was like, install. That's what the message was. I named it Light Switcher. Let's check. Do these PCs, this was a Unity. All right, so an empty is an object with only one component. All objects in a scene are game objects. This is a game object, just like anything else, are empty. And you know it's an empty because it only has this one component. We're going to add another component, a script component. So just click the Add Component button and add a new script. New script. We'll call this Light Switcher. And you wait for that little hamster wheel to finish. Light, the same name. It's a new script, so add component, new script. Did you select script? Did you select scripts, Cesar? Just at the very bottom, it's new script. Hmm? Perfect. What's up? Yeah. See, that's scripts that you're doing. If you go back out of this, let's go down to the very bottom, new script. No worries. And I gave this new script the same name, Light Switcher. Let's open it up in our coding thing of choice. If you're very lucky, your autocomplete will be working. Mine is not. And you'll also see that the script has been created in our assets panel right down here. Open in Visual Studio, yep. Or Sublime Text, whatever you're using. But Visual Studio comes with Unity, so you should probably use it. So reasons for using private. It keeps cleaner code because you only have to worry about this variable in one script. Reason for using public, you need to communicate with other scripts or external objects. We have a light switcher. We have the light switcher script. Okay, create an empty. Yep. Perfect. And you have the script on the light switcher object. Open the script. UNITY is Unity. Nope. 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 That was just me demonstrating what I did. So here we have our standard first two methods. They are produced in every single mono behavior file. They start and they update. They say what they do. Called once before the first execution of update and after the mono behavior is created. So it runs once, update runs every frame. We create our variables outside of these. I'll make a public light, capital L. And autocomplete is not helping me. Okay. What would you like to use instead? Mm. Yeah. Do you have another code editor? Yeah. Yeah, you can set that. I'll just show you now, but you can set that inside of your stop auto-completing. There we go. My lights. Do not autocomplete to light switcher. All right, there we go. My other light. Okay. So the exact same as in the notes. My light, my other light, semicolon on the end of each one. Your question is about changing your code editor. I believe it'll be in preferences. There we go, project settings, editor. You have to open some external code editor. It doesn't have to be Visual Studio. Where am I looking here? Wrong one. Yeah, there we go. Okay, Bergman. If you want to go to external tools in preferences, you could say what script editor you're going to use, and that's for everybody. I'm using Visual Studio 2022. But if you want to change it to something else, you can. No, preferences. You're in project settings, which is different from. Is there no preferences? Of course, yes, it is something different. And where can I find the preference? The edit menu. But in Visual Code is a little easy. Mm. But I don't know. Like they open a Visual Code. Yeah. But it's just it's for different. Maybe you can write external tools over here. Yeah, that could be an idea. Anyway. So light switcher, if you save your file the way it is here with just these extra bits, we should see a public slot for my light, and we won't see anything for my other light. So back in Unity, we'll be able to see there is the other light right here. Script my light and an empty slot where we can put a light. Yep. Which week is that? 7 or 8? Which week for? Where is the slides? Oh, yeah, week 8. Topic 8. Week 7 was last week. Game 1? Yep. So we put capital L for light, and that defines its type. So the type defines what kind of value the variable is holding in memory. It can be a number, text, or more complex types, like transforms, lights. So Unity needs to know what type of object it's working with before it knows what to do with it. Another important thing about variables is the name. When you're naming variables, it's important that it cannot start with a number and it doesn't contain spaces. In C#, the standard naming convention is camel case, like the humps on a camel. We start with a lowercase, and then any new word we capitalize with a capital word. There are others: screaming snake case, lower snake, words on a skewer, upper camel Pascal case, but the standard that I always see is camel case for variable names. That's a good convention to stick in. So if we want to make some other types of variables, what other variables are there? Integers is one. We could make an int, meaning a whole number. My number. We can make a float. My float number. 5.2.f. Or we can make a string of characters. Because all of these are public. Once I save and go back to Unity, not important. Once I save and go back to Unity, you can see there are all of my variables because they're public. Just note that I'm using camel case, lowercase first, and then the humps of the camel for every new word. Yep. Which? Which Visual Studio is it? Why? No, I have the same project from last week open. I made a new script. You have a new script. And then I opened it in Visual Studio. Yeah. Push. Yes. Yep. Yep. Here it is. Here's the script. Yes. By default, it connects to Visual Studio, but you can check in your edit preferences. Okay. Okay, so you know what I did then. Yeah. So Visual Studio 2022, that's what I'm using. And that's it. So then when you double click on it, or any script, there we go. It opens up. Yeah. But it's the same as opening it in Windows Explorer. You double click on it, it'll open in Visual Studio. We're just editing it. Yeah. Yeah. Functions. In order for us to do anything with our lights, maybe enable, disable, we need to create functions. There's a number of functions that run automatically inside of Unity, and then we need to make our own custom functions to do things we want. Awake, start, update, fixed update, and late update in that order of running. Awake is called before start. It's called only once when the game object with that component is instantiated. Instantiation is a very powerful tool in games. Very important. It simply means bringing into existence, making duplicates of one asset again and again. This will minimize memory load by just having one asset that you can keep replicating again and again as you're shooting. You have one prefabricated asset and you can just keep duplicating. If a game object is inactive, then it will not be called the awake method until it is made active. So basically, when it wakes up, it'll run this thing. Use awake to initialize all the variables you need. Start is very similar. The only defining feature is that it happens after awake. So if you need to separate awake from start, let's say awake, you want all your enemies to instantiate across the map. And in the start method, you want them to start their patrol. You could separate them out in that order to make sure everything is loading in the right order of operations. Update is called once per frame. And as fast as our frames are running, as fast as they will execute. This is where we put code to define the logic that runs continuous, like animations, AI, and other parts of the game that have to constantly be updated. Input is a major one of this because we want to constantly be checking for key presses, for button presses, whether the user is playing the game, inputting, or clicking on the screen. So that's what we're usually checking at all times for. Fixed update is when you want to do physics work. So the reason is that update refreshes on every single frame, and fixed update only goes in step with the physics engine. So basically, as much as they update the graphics, the gravity and physics and rendering stuff of that is when fixed update happens. So if you're manipulating stuff with physics, rigid bodies like we looked at last week, use fixed update. Jumping would be a fixed update thing, but I'd say, yeah, you do the physics manipulation in fixed update, but then the key presses in update, because jumping is one you want to be like really precise, but really accurate. But yeah, movement I'd probably do in fixed update, and then yeah, jump in update. Late update, called at the end of the frame. Unity looks at all the game objects, find all the updates, and then call the late updates. Common use for this is camera. You make sure that your character is completely moved before you update the camera. Let's go back to Unity and use one of these functions and create our own. So I'm back in the light switcher scene. I'm going to create a ground plane. So let's create some 3D objects. Let's give ourselves a plane for the ground. I will call it ground. I sure can. Game object, 3D object, plane. Nowhere near my camera. Let me just check my position of this. I'm just going to put its position back at 0, 0, 0. So I've zeroed its position. Hey, we can see it now on the camera. Good stuff. And let's add a point light into our scene. So another game object. Light. I'm going to add a point light. You can change the color if you want. Just want to make this more noticeable, so I'm going to change its color. I'm going to increase that intensity a little bit. Yep. Only thing I changed was color and intensity. Let's duplicate the light. Control D, or I believe it's in here, edit, duplicate. The light. So you should have two lights. I'm going to make one blue. Which bar? Oh, status. That'll be in Windows, surely. This? Yeah. You're asking such great questions. Okay, it's gonna be in this. Icons. List. Panels. We've got console. We've got layouts. Super series of blah, 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 blah. I didn't do anything to enable any bars, but if I move it, no. I don't know. I'll try and help you with that layout thing later. Let's just focus on the coding part for now. So we have two lights, one red, one blue. We also have a third light, the directional light, which is the sun. If I turn it upside down, you can see it's pointing away from the earth, so it's dark. You also see when I rotate the sun in the sky, that's where the sun is. It's in there by default. It is the directional light. Every scene will have it. You do. I swear to God, if you make me get out of my chair and tell me there's no directional light, I'll kill you. I'll kill you. But you're right, there is no directional light. You can just delete it and add a directional light. Delete light 2D. It's a simple 2D project. Delete it. Add another light. All right, so you can delete the direction light or you can point it away, whatever you want to do. I'm just going to point it up to the sky. So two lights. Which, this? No, they're both point lights. And I'm going to name them red point light and blue point light, so we know exactly which one's which. Back to the script. No. So we don't need these. They were just tests. If you type those, good for you. We also will not need our start method, so we can delete that too. So here's what I have. Update and my two variables. So what I'm going to do is we're going to create a short function that's going to switch our light from on to off. So we've only made scripts one way. We've added it as a component. We could make a script from Unity just by going to Assets, Create, Script. I might say C# script if we're using 2022, but we'll make a script and it can be about anything. Script, and then you just type enemy AI or whatever you're going to name your script, and it will save it there. So it's the same as adding a new component. It's just adding it into there. We don't need to add another script. I'm just doing it as a demo to show something. Now, back to the script. So we're going to create our own function. It'll be a void function because we're not returning a value. And what we're going to do is take our lights enabled status and flip it. So here's the name of our variable, dot enabled. And we'll set it to exclamation point, my light, not enabled. Exclamation point in script means not or opposite. So if this light is on, it will change its status to off. But if this light is already off, it will flip it to on, which is why we use the not selector. Just like we have a definition for the direction up, vector 3 up, we don't have one for down, we just say not up. Not up is down in C#. So this is very useful, other thing. You'll find it useful later on, but just being able to switch from one to the other. So this will be the function that switches things over. Let's create that function. Back in script, and we can write it before update, after update. I'll write it before. Void switch lights, open and close parentheses, open and close curly brackets. And we're going to take the name that we put up here, my light. The other variables, yeah. The other variables are gone, yeah. Just these two. My light dot enabled is equal to not my light dot enabled. And then we want to be able to switch this using input. So we're going to use our update command. And we're going to add an input command in here. There's so much in input and in everything with Unity that you will find yourself looking for Unity reference quite a bit or Stack Exchange just to find the right syntax. But you see here we reference Unity's input, and it always starts with a capital I input. And then these types of commands exist for mouse buttons for key presses. So get mouse button down, get mouse button, and get mouse button up are three different ways of interacting with the same button. They're numbered from 0 to 2. As I say, left click is 0, right click is number 1, middle click is number 2, and this works the same if you're coding for touch devices, Android, that will count as a double touch. Same code, you don't have to write anything different. Yeah, so if you're developing for touch, then just use get mouse button, it will read the same way. So we're going to use mouse clicks to change over. Let's make another variable type. What's a bool? Come on, you remember bools? Your old friend Bools, invented by George Boole. What is a bool? Yeah. What is Boolean? You need a gold key to open a gold door. A bool is a true or false statement. I like to store key presses and input as true or false statements, whether it's true or false you're pressing. It just makes my if statements easier. So I'm going to store this as bool. Left mouse button. Get mouse button down 0. Let's make one for the right mouse button. Bool or MP equals input. Whoops. Get mouse button down 0. No, wait, you're right, 1. The next thing we need to do is check whether or not the button is being pressed. What do we need to check? Who said it? If. Yes. So yes, we need an if statement. Let's if it up. If LMB. And then all we need to do is call our switch lights function, and that's going to switch our light on or off. Switch lights. And back in Unity, we're going to have a variable to set. Save my file save. Jump back to Unity. And on light switcher, you see we have a variable for light. Just use your little selector dot here to grab a light from your scene. Red point light. And now we can test. Very interesting. I can. But just to test, if I'm clicking, you can see that light is going off and on. And yeah, just to demonstrate, again, some people weren't here last week. If I make changes inside of play mode, they're not going to stay. So for example, if I start duplicating, I'm creating more lights. Or I start adding things like walls, all of this extra stuff I've added is only there while I'm in play mode. The second I leave play mode, it's all going to revert back. So these extra walls I've created, gone, because I only created them in play mode. Now, what was the question? Let's see the script one more time. So the other light, we want to create a command for that. We can just do another if statement, if or MB. And instead of switch lights, I could just write it the long way. My other light. is equal to not my other light. Not enabled, I should say. And then I can't assign because I cannot see. It's private. So I'm just going to change that to public. Here are the changes I've made. Change this to public. I've added an if right mouse button. Couple of different ways. I mean, you could right click and change view like that. Right click view, or you can double click on what you want to look at. Double click on the pointer and get closer. Double click on the ground and focus on that. So there's that. There's also option and left click. You want to hold option. So this should be working. That was control option. That lets you orbit around like this. Select it and then zoom in and out. Oh, there's one more. It's all in the notes from last week, but as you hold right click, use WASD to fly around. So if you press W right now, oh, when isometric, press S, go back. That, yeah, perspective is more the flying around things. Yeah. Different ways. Yeah. Yeah, so just we can just drag the script onto the light switcher. And then load the lights, drag them in there. Yeah, literally like that. You've deselected it now. You have to select the light switcher again. There's also a little selector dot that I use on light switch. No, no, you've already had the script on it. You've added, so you can speed up. Yeah, that just lets you pick from the lights you have. So now, if you assign the public variable and you test, you should be able to right click, turn the other light off.
How can I test?
Why not? What's up? The name input does not exist in the current context because input is referring to a type inside of Unity, capital I. What is it?
Yeah, I cannot still, and I can see the device.
We did not finish, sir. I'm not going. Didn't run anyway. All right. So if you test right now and your input is working, you should see that you can flick with the left mouse button and the right mouse button between the two. Oh, this shouldn't be loading this long for something so simple. Mother of God.
Yes,
I can see this
I did.
as you didn't say.
I did.
And now when this comes back,
Yeah, like suits.
and how upset he was. He was like, wait, I'm not finished, sir. Come over here and save my file.
Yeah, you have to save. Yes, you do. Thanks so much. I
And just
appreciate it.
make sure it comes back.
Yeah, yeah.
Yeah, there it is. Yeah. So select the light switcher again. Don't play. Because you've gone empty. Add your lights. The little selector dot here. Select your light. Point light. One, two. Oh, I still cannot right click to select it because I've left it blank. So remember your little selector dot. Blue point light with that little selector dot. You can say I can pick the directional. I can pick any of them. But blue point light. Just adding some walls so we have more to bounce the light off. And I'll pull this camera up. Left click, red light on. Right click, blue light on. functions can do calculations and then return a value. And if we select void, it's not returning a value at all. Classes, and we've just been reading from a Unity class, the input class. These are collections of variables and functions. So this script is a class, this demo script is a class. The script we're creating is its own class, deriving from MonoBehavior. So we've made our own class called LightSwitcher, and that's based on MonoBehavior. So got one rule, the class name and file name must match. And then in order to work with a game object in Unity, it has to derive from MonoBehavior. If you don't choose one based on MonoBehavior, you just have to declare it to the system as system serializable. But never mind that. Let's talk about return functions. Here is a function. What do you think it does? It takes an int, add2. It's got what I know as arguments, but I've heard other people call them parameters. Exactly. Yep. That's exactly. It's just adding two numbers together, var1 and var2, returns the value of var1 plus var2, return value. But once you've written a function like this, you can call it again and again, and then you decide what the variables are. So this one's called int myvar add2 9 plus 2. We could create our own function to multiply 2. I'll call it int multiply 2. And it's going to take two variables, int x, int y. We create another int called the answer, or the returned value. In this case, we want to multiply the first int by the second int, x times y. And then finally, the most important line, we have to have a return line. Return the answer. And then finally, to use this somewhere, we just need to call it in a function. Maybe we're pressing our mouse button down. In fact, let's add another control. Bool LMB underscore up. Up. So mouse button down when you press down, mouse button up when you release. So say if you're playing a fishing game, you want to charge up your reel, release. Actually, I shouldn't do camel case when I'm talking about, or yeah, LMB up. So I create an int for the answer, multiply 2. It's 22 times 22,222. Easy number, everyone knows it. And then this is a debug log. It means it's going to print the answer to the console. Great for testing, making sure things are working. go back to Unity, and now when I press down on the mouse button, a light's going to change. When I click up, when I let go, it's going to give me the answer 22 times 2,222. There's my console. Hey, and the answer is 48,880. No, wait, 488,884. So nearly 500,000. Click down, turns off, click up, gives me that answer. So it's doing the calculation. And that's our short introduction to variables. I'll put the